Hey guys, welcome back to my channel, The Math Part, and today we're going to do sine and cosine rule. So we're going to begin with first understanding what the sine and cosine rule are and in which type of shapes are used. So if we start with the sine rule basically has a formula of A over sine of angle A equals to B over sine of angle B equals to C over sine of angle C. Now, in this, in what's it called, non-right angle triangles, we mostly use sine and cosine rule. The reason being is that we cannot apply Pythagoras to these triangles because we don't have a right angle triangle in this case. So keeping that in mind, the most ideal options are sine and cosine rule. In a triangle, as you all know, we have three angles and three lengths. So if this is angle A, the length opposite to that is called length A. Similarly, if this is angle B, this will be called length B, and this will be called length C. So since we have like a triangle in our mind, and we have the formula over here, now we need to understand when we can apply this formula. So sine rule can be applied when we have like a complete set of angle and length. When I say a complete set, let's say if we have the measurement for angle A and length A, and let's say we're given angle B and they're asking us to find the length B. So we can easily use the sine rule using that one complete set that would be used in the given formula to find the unknown. So keeping that in mind, I'm going to write the conditions over here. We need one complete set of length and angle. For example, length A and angle A. So now keeping the condition in mind, let's look at the question. The question says that we have to find the length AC. Now they've given us CB, they've given us angle A, and they've given us angle B. So if this is B, then this would be small b. This would be small a, and this would be small c. So they're asking us to find the small b. If you look at the given information, we have one complete set. We have angle A, we have length A, we have angle B, but we don't have the length of B. So what we can do is we can easily use the sine rule over here and say 8.15 over sine of 110 equals to B or AC. Let's go with AC because there's AC over sine of 30. Cross multiply, that all the known values are on one side and the unknown is on the other side. I'll just plug in the equation in the calculator, and 8.15 times sine of 30 divided by sine of 110. So that's 4.3. 4.34 meters is AC. Now, if you're wondering why we only use two fractions in this case, the reason being is that the unknown that we're trying to find is AC. And find AC, we only need two fractions. We don't need the three fractions. Whenever you use the sine rule, we only use two fractions, depending on which values are given and which ones we need to find. So, yeah. And if you look at this question, it says find the value of x. So in this case, we have, let's call this A, call this B, let's call this C. So this is angle A, this would be length A, this would be length B, this would be length. So over here now we have two lengths, one angle, and they want us to find the other angle. So if you notice, we have one complete set over here. We have angle B, we have length B. So we can do 39 over sine of 71.8 equals to 24 over sine of x. Cross multiply, sine of x equals to 24 times sine 71.8 divided by 39. Plug in the values in the calculator. So that's going to be 24 sine 71.8 divided by 39. That's going to be sine of x equals to 0.58459. We take the inverse of this. Always remember, whenever we're trying to find the value of the angle, we will take the inverse of the trig ratio that we're using. So sine inverse of 0.58459, and that's 35.77 degrees. That is your answer. Now in question 3, what we have is three lengths, and we have to find the value of an unknown angle. We don't have either of the angles in this case actually. So if we notice, it doesn't qualify for the sine rule. So if the triangle doesn't qualify for the sine rule, automatically you go to the cosine. Cosine rule has the formula of a squared equals to b squared plus c squared minus 2bc cos of a. Or there are like three different versions actually for this, depending on what the unknown is. If let's say we're trying to find b, so it could be b squared equals to a squared plus c squared minus 2ab cos of b. If we're trying to find c, then it would be a squared plus b squared minus 2ab cos of c. So as you can see, the formula is the same. It's just that the variables are changing depending on what is the unknown. And in case we're trying to find the angle, the formula becomes cos of a equals to a squared minus b squared minus c squared over negative 2bc. We're trying to find angle b, it becomes b squared minus a squared minus c squared over negative 2ac. And if we're trying to find angle c, it's going to be c squared minus a squared minus b squared over negative 2a. Now you don't need to remember all of these, like you can just remember the first one, and like you can just like change the variables depending on what the unknown is. Like you'd be good if you know the first one. So now the condition. Cosine rule is applicable when you need all three lengths. For this, we need all three lengths, or you have two lengths and the angle between. If your triangle qualifies for either of these two equations, either of these two conditions, sorry, then like, you can apply the cosine rule. So if you look at the triangle, for our case, it qualifies with the first condition where we need all three lengths. And since we have all three lengths, which means we can use the formula, we can use either of the formulas for the angle ones to find P. So if we call this A, B, P, then this is small a, small b, small c. So in our case, we're trying to find the angle B. So we can use cos of B equals to b squared, which is 5.3, square minus 3.6 square minus 2.8 square divided by negative 2 times 3.6 times 2.8. Yeah. Now we just plug this all in the calculator. You know that 5.3 square minus 3.6 square minus 2.8 square. This all is divided by negative 2 times 3.6 times 0.8, which gives us negative 0.361. Negative 0.366. And then you take cos inverse of that. When we take cos inverse of that, that gives 111.2. 111.2 degrees is your value of P. Then if we go to the next question, in the next question it says in triangle ABC, AB is 6 centimeters, BC is 13 centimeters, angle ACB is 23 degrees, calculate BAC, which is obtuse. So what we can do over here is, since we have one angle and its corresponding length, so which means we will use sine rule. So we can do 6 over sine 23 equals to 13 over sine of A. Cross multiply, so sine of A equals to 13 times sine 23 divided by 6. Sine A equals to, love this calculator, so 13 sine 23 divided by 6 gives us 0.84658. We take sine inverse of this because we're trying to find the value of the angle. So sine inverse of 0.84658 gives us 57.8. Now, as you can see, 57.8 is not an obtuse angle. So to find the obtuse angle BAC, what we'll do is we will subtract this from 180. So that gives us 122.2 degrees. That is your answer. If you have any questions or confusions, let me know in the comments below and I'll help you out.